Welcome to Formula 1 Maths. This is past exam question 008, higher tier, GCSE. We've got 3 questions to answer. Question 1. Given that 2 plus root 20 over 7 plus root 5 is equal to a plus b root 5 over c, and that c is a prime number, find the values of a, b, and c. To answer this question, we will need to rationalize the denominator of the left-hand side. To rationalize the denominator, we will need to multiply both numerator and denominator by the conjugate of the denominator. So the denominator is given by 7 plus root 5. The conjugate of this is given by 7 minus root 5. So all we had to do was to change the sign from positive to negative over here. If this was negative, then the conjugate will have a positive over here. So we're going to multiply numerator and denominator by 7 minus root 5. The next step will be to expand both numerator and denominator. But before we do that, we need to simplify root 20, because root 20 can be written as root 4 times 5. But the square root of 4 is 2. So this will give us 2 root 5. So now we can replace root 20 with 2 root 5 as follows. We can now expand numerator and denominator. 2 times 7 will give 14, and then 2 times minus root 5 will give minus 2 root 5. The next multiplication will be 2 root 5 times 7. That will be 14 root 5. And then we will do 2 root 5 times minus root 5. So we have 2 root 5 times root 5. That will be equals to 2 root 25. And that will give us 10. So the whole of 2 root 5 times minus root 5 gives us minus 10. The denominator is the difference of 2 squares. So for example, if you have a squared minus b squared, that's a square and that's a square. So this is what is referred to as difference of 2 squares. We can factorize this as follows. A plus b times a minus b. So looking at the denominator critically, it looks exactly like the right-hand side of this equation. So this is 7 plus root 5 times 7 minus root 5. And this will be equals to 7 squared, that's 49, minus root 5 squared, which is 5. And that will give 44. So we are going to get this here. And as you can see, we've got a 14 over here. We've got minus 2 root 5 over there. 14 root 5 over here. And minus 10 over there. We can now collect like terms. And as you can see, 14 and minus 10 are like terms. So these two are rational and they are like terms. And these two are also like terms because they are both irrational. So if we collect like terms, we're going to get this. 14 minus 10 and then minus 2 root 5 plus 14 root 5. We can simplify by adding the like terms. 14 minus 10 is 4, and minus 2 root 5 plus 14 root 5 is 12 root 5. And so our simplification will give us the following. At this point, you may be tempted to write down the values of a as 4, b as 12, and c as 44. But that is not the answer required because we are told that C is a prime number. So it means we need to simplify this further. And so 4 comes up, we are going to get 4 brackets 1 plus 3 root 5 over 44. I can now simplify this fraction by dividing numerator and denominator by 4. So if I do that, I get 4 goes here 1 and 4 goes there 11. And so finally, I have the left-hand side being equal to 1 plus 3 root 5 over 11. I can now compare the left-hand side and the right-hand side, and I'm going to get the following. So comparing left-hand side and right-hand side, we can now write our values for A, B, and C as follows. So A is equal to 1, B is equal to 3, and C is equal to 11. And that is question 1. Question 2. Find the coordinates of the turning point of the curve with equation y equal to 16x minus 7 minus 4x squared. You must show all your working. First, I will rearrange this equation and make minus 4x squared the first term, 16x the second term, and minus 7 the third term. And I'll get y is equal to minus 4x squared plus 16x minus 7. I need to complete the square for this quadratic equation. I will need to factorize minus 4 out. And so if I do that, I'm going to get minus 4 brackets x squared minus 4x, because minus 4 times minus 4x gives plus 16x, and similarly minus 4 times 7 over 4 gives minus 7. I can now complete the square inside this bracket here. So let's do that. So x squared minus 4x plus 7 over 4. If I complete the square, I'll get x minus 2, because 2 is half of 4. Then I'll square all that, and by squaring that, I have added the square of minus 2. So I need to take that off, and the square of minus 2 is 4. I will then add the 7 over 4 to it, and I'll get that. I can then put this inside the brackets because they are equivalent. So if I do that, I'll get this. So what is in the square brackets is the same thing that I've got here. I can now expand the square brackets to get this. So I'll get minus 4 times x minus 2 all squared, and minus 4 times minus 4 plus 16. Minus 4 times 7 over 4 is minus 7. But 6 minus 7 is 9. So the equation reduces to this. So I've finished completing the square. But I need to rewrite this in a way that will enable me to write the coordinates of the turning points easily. And that is writing it in this form. So that's 9 minus 4x minus 2 all squared. So by doing that, I can easily find the x and y coordinate of the turning point. Now at the turning point, y has a maximum value given by y max. And so this equation here, y equals to 9 minus 4x minus 2 squared must be a maximum at the turning point. So for this to be a maximum, we need to take as small a value as possible from 9. And that means this here must have smallest value. And because this is a square, the smallest value it can have is 0. So for y max, this will be 0. And that means we have 9 minus 0. And so the maximum value of y is 9. And so we get y max equals to 9. As I mentioned earlier, the smallest value of this must be equal to 0. And this will occur when x minus 2 squared equals to 0. It therefore implies x minus 2 equals to 0, and that means x is equal to 2. And so our x-coordinate will be equals to 2. Now, in an exam, you don't have to do all these analyses here. After writing it this way, you can immediately see what the x-coordinate is, and hence what the y-coordinate will be. So when you write it this way, the x-coordinate is given by the value here negated. The value here is minus 2, and if you negate minus 2, you're going to get plus 2, and this is what we got here. And that will be your x-coordinate. For the y-coordinate, the whole of that will be 0, and that means it will always be this value here, and that will be 9. And so that's how you can easily write down the coordinates of the turning point. And so that's question 2. Question 3. The area of a trapezium A, B, C, D is 70. The length AB is 8 centimeters. The ratio of the length AD to the length BC is 2 to 5. Find the length AD, which is this length here. We are told that the ratio of this length to that length is 2 to 5. So we don't know the actual lengths. So we can say that if AD is 2x, then because of the ratio here, BC will be 5x. We are given the area, which means we will have to find the area of this trapezium. That means we will need the perpendicular distance between the parallel sides. And so let's label that H. We are also given that this angle is 150. And because this length is perpendicular to both parallel sides, it means this angle is 90. If this angle is 90, then this angle will be 150 minus 90, which should be 60. Again, because this length H is perpendicular to both BC and AD, this angle will be 90. And that makes this triangle a right-angled triangle. We can go ahead and use SOHCAHTOA to find this length, H. So we can do cos 60 is equal to H over 8, adjacent over hypotenuse. Rearranging that means H is equal to 8 cos 60. This is a non-calculated paper, so you should know the values of cos 60, sin 60, tan 60. Now cos 60 is a half, and so that will give us 8 times a half. I can cross this one out to get 4 here, and that means H is equal to 4. So we have established that H is equal to 4. Now we are told that area is 70, but the formula for the area of a trapezium is given by half brackets A plus B times H, where A and B are the parallel sides and H is the height. So in this case, we can say our A is 2x and B is 5x, and then the H will be 4. So we can do the substitution and get this. Half brackets 2x plus 5x times 4 is equal to 70. Now this, I can cross out this one to get 2 here, and so I'll get 2 brackets 2x plus 5x to give me 70. I can divide 70 by 2, and I'm going to get 7x is equal to 35, because 5x plus 2x is 7x. Then if I solve for x, I'm going to get 5. But we are looking for AD, and we know AD is 2x, but x is 5. So that means AD is equal to 2 times 5, which gives us 10 centimeters. So your length of AD is 10 centimeters. And that is the end of this session of past exam questions 008. Thank you for watching, and I'll see you in the next video.